Hi everyone. In this one we are working on an oil tanker that has hit a reef and is leaking oil. The oil is forming a circular slick that's about 0.1 feet, a tenth of a foot thick, let's say it that way. To estimate the rate at which the oil is leaking from the tanker, someone's measuring the radius of the slick and found that the radius was increasing at 0.32 feet per minute, about a third of a foot per minute, when the radius is 500 feet. And we want to figure out how fast the oil is leaking out of the tanker, how much oil is leaking. Okay, so let's see. It's a circular slick, and I don't see anything in there that says the thickness is changing, so I'm just going to label that as fixed, that it's staying about 0.1, a tenth of a foot thick. Let's see, we are to estimate the rate at which the oil is leaking from the tanker. It is found that the radius of the slick, okay, so the radius of the slick is changing, so we'll call that R. It's increasing by 0.32 feet per minute. Okay, so that's the rate of change of the radius with respect to time. And that's happening when the radius is 500 feet. And at what rate is oil leaking? Okay, so if we want to figure out how fast oil is leaking from the tanker, measuring oil, that's going to be a volume measurement. So we want to find dV dt, where V is the volume, and I'm going to say volume of the slick, although you could say it's the volume of oil in the boat, I think, but that seems a little more confusing to me. I could figure out the volume of a slick. Okay, so volume of the oil slick. So here's the thing that's really important. People just want to say that oil slick is a circle, but it's not. It's actually a really short, flat cylinder. So the volume formula that I'm looking for is the volume of a cylinder. So it's the area of the circle, pi r squared, that's the base, multiplied by the height. In this case, the height actually is fixed, so you don't have to put an h in there. If it really isn't changing at all in the problem, then don't make it change at all in the equation, just fix it. And I can take the derivative of that. So the derivative of the volume function with respect to time, okay, so the r squared is the only variable stuff. The pi and the 0.1 are constant multiples. They'll come along for the ride. The 2 drops down and it actually becomes a 0.2 pi. And then it's r to the 1, and then there's a chain rule. So there will be a dr dt. We were given dr dt and r, so we get that dv dt is 0.2 pi r 500, dr dt 0.32. Okay, let's see if I can keep up my lazy calculating. 0.2 is 1/5, so we get 1/5 times 500, so that's a 100. 100 times 0.32 is 32, so I'm seeing that dV dt, you guys can recheck me and fix my number if I'm wrong, is 32 pi. This was the volume of the oil slick, so this should be cubic feet per minute. Volume should be in cubic feet. And then I do want to think about this a little because this is the volume of the slick. The volume of the slick is increasing by 32 pi cubic feet per minute, and the question was really at what rate is the oil leaking from the tanker, but I actually think we're still fine to say that. The amount of oil added to the slick is exactly the same as the amount of oil lost from the tanker. All right, thanks for watching.